All right, welcome back. So, all this stuff that we extract out of the ground, these valuable economic resources, where do they come from? So we'll take some time to kind of break these down. This section's a little long. Deposits of economically viable rocks and minerals, they form in a variety of different ways. Something called magmatic, from magma, hydrothermal, hydro water, thermal heat, hot water. They form from or in sedimentary deposits or something called placer deposits. So we'll take time to break down each of these. The first one we'll talk about is magmatic ore deposits. These are substances that are concentrated within a body of igneous rock by magmatic process, by the process of hot magma bubbling up towards the surface. It's during that process that certain valuable ores are deposited, this stuff we extract from the ground. Within the magmatic ore deposits, there's a few different deposit types we can talk about: pegmatite, layered settling, and kimberlite pipes. So we'll take time to break down each of these kind of separate magma ore deposit processes. So pegmatite. Pegmatite is usually a coarse-grained igneous intrusion. It's usually single crystals, big single crystals that can be well over 30 feet long. So as magma is cooling, crystals begin to form. That's a good indication of igneous rocks, a bunch of crystals kind of, embedded together. But sometimes, depending on the cooling process, if that process happens very slowly, then minerals tend to grow big. So single crystals of certain minerals can be huge, well over 30 feet long. Many pegmatites are also enriched in very uncommon elements. So typically, gemstones like tourmaline, beryl, which is where we get emerald or aquamarines, just as an example. So here's an example of a tourmaline pegmatite, or here what you see in aquamarine. So when we see these big crystals growing, these are called pegmatites. The type of rock that we find these big crystals in are called pegmatites. You know what? Oh yeah, I do. I have some. Okay. Now this isn't anything of value. Let me just blow me up here real quick. All right, so this isn't anything of value, but this would be considered a pegmatite granite. So it's granite with big crystals in it. So you can see this big kind of crystal here, which might be some sort of hornblende or even black tourmaline. It has no value to it, but you can see the big crystal. All right, you can see the big crystal there. So this would be a pegmatite, a granite pegmatite. So sometimes we see these big mineral crystals embedded in these rocks. And again, that's due to as magma is cooling, if it cools very slowly, so kind of deeper underground where it takes a long time for that heat to dissipate, the minerals tend to grow bigger and bigger. They have more time to cool and grow. So they become bigger and bigger. So that's pegmatite. And again, oftentimes these are your gem quality minerals that you're finding in these igneous pegmatites. Excuse me. So we also have a magmatic process called layered settling. So as a magma body begins to cool, as this liquid hot magma begins to cool, different minerals will start to crystallize at different temperatures. So as some crystals start to form, they become more dense as they start to form a solid from this cooling liquid magma. These dense crystals will then begin to sink to the bottom. So as these crystals of minerals start to form, they begin to sink to the bottom, and they kind of form a layer at the bottom of this kind of magma chamber, which could be, 100 miles wide. Oftentimes, these types of layered settling deposits can host copper, nickel, platinum, palladium, rhodium, chromium. So a lot of metallic minerals can be found in these layered settling deposits. And you can kind of start to see those, layered settling deposits. They look like layers, not like sedimentary layers. Well, I guess similar-ish to sedimentary layers, but these are igneous rocks. Typically, you don't find layers in igneous rocks. When you do, this kind of indicates maybe a bottom of the magma chamber where these materials started to settle down. So it looks like it forms layers like sedimentary rocks, but when we look at them, no wait, these are igneous rocks. And then something called kimberlite pipes, as far as magmatic ore processes creating valuable materials. So a kimberlite pipe is an ancient volcanic neck, a conduit that transports ultramafic magma. So this is very dark, very heavy magma from kind of deep in the mantle. So more kind of deeper down in the mantle, not like in the middle of the earth, but just in the mantle, which is still kind of very close to the surface, but way below the surface. Let's say that. So carrying this kind of very interesting mineral blend of this very heavy dark magma kind of coming up towards the surface. Diamonds are very commonly found in these kimberlite pipes because diamonds are formed at great temperatures and pressures. So way deep down in the earth, way in the mantle. So in order for that stuff, these diamonds, which diamonds form way deep down, to get to the surface, they have to be kind of transported up. And kimberlite is a type of igneous rock, and so as this magma is making its way to the surface, it may or may not erupt, but it cools, it crystallizes, and then over time you're left with this, what looks like almost like a big pipe of igneous rock, this type of igneous rock called kimberlite, in which diamonds can be found. The process that emplaced these kimberlite rocks, these ultramafic, very deep down rocks, is no longer common on Earth. So volcanoes don't produce kimberlite anymore. The volcanic processes that produced these types of volcanic eruptions, they don't occur anymore. They only occurred 2.5 to 4 billion years ago when the Earth was still forming. So something with plate tectonics and how the Earth was still forming allowed for this heavier, deeper, dark down magma material, this ultramafic magma material from the mantle to make its way up. And when it did, it brought with it those diamonds that also formed way deep down at those depths. That process, with whatever was going on Earth, it doesn't exist anymore. That plate tectonic and the early formation of the Earth, that's not what we have now. Therefore, we don't have these type of magmatic processes, these kimberlite pipes. So we don't have, new diamonds coming to the surface. We just find the diamonds that we got. So diamonds were created. So if you have a diamond, more than likely it was created billions of years ago. We mined it out from these kimberlite pipes, but that process no longer exists. Before we go on, let me give you another part of the super secret code. It is the number 3. You got me? The number 3. One more time. The number 3. So here's an example. So some ancient magma source where diamonds are formed brought with it those diamonds as they came up. So there was at the surface some ancient kimberlite volcano. All this material has been eroded down to the modern surface we see now, but there are these volcanic necks, these what are called kimberlite pipes, because it looks like literally a vertical pipe of rock making its way to the ancient surface. It's no longer there before, it's all been eroded down, but it's in this kimberlite pipe. It's mining out this kimberlite pipe that we find diamonds. Most often we find diamonds. And when we find diamonds, what you see in a ring or in jewelry, those are cut and polished. This is what a raw diamond looks like in kimberlite. Ultramafic, very dark, igneous rock. Very heavy, very dense, very dark igneous rock. So here's a kind of zoomed in version. That's what a natural diamond looks like. So where do we find these kimberlite pipes? They are heavily concentrated in South Africa. South Africa, the southern portion of Africa, very famous for diamonds. Also in the northern reaches of Russia. You also get some in North America, but definitely up into northern Canada. So when we're looking for the blue, that's the major primary kimberlite deposits. So you get a few in South Africa, a couple in Russia, one way up in northern Canada. Yellow, a little bit minor, but again, South Africa, some in Asia. You do get some in the U.S. area, but a lot of times, sub-economic. These aren't worth the orange and red. You can find diamonds, it's just not worth economically all the money you would put into extracting those. So you're looking for the yellow or definitely the blue. And if you notice, those yellows in the blues and most of the oranges and reds are in these kind of blue blobs. It's kind of down here in the corner. That's called a craton. A craton. So these blue blobs are called cratons. Cratons, if you look down here at the bottom, is an old but stable part of continental crust that has survived plate tectonics. It survived merging, splitting, convergent, divergent, transform. It survived all of those. It survived splitting of continents, the coming together of supercontinents. These are some of where the location of some of the oldest rocks on the Earth. All right, these cratons, the original pieces of Earth, the oldest pieces of Earth that we know of that haven't been recycled. And if you notice, again, these kimberlite pipes are typically only found, typically, not always, but typically only found along these cratons. Because again, the process that created these kimberlite pipes only occurred 2.5 to 5 billion years ago. So any of these areas are rocks that are about 2.5 to 4 billion years ago. So there is a high concentration of these pipes in these cratons, these original pieces of crust. Stuff got added to them, but these pieces, nothing has really altered these pieces, recycled them. They are what they are. So a typical diamond mine in these kimberlite pipes, they may have previously mined it from the surface, mined down, but then when you get to a certain depth, it's just too much to keep digging kind of down from the surface, so they do below surface. So this is when they start to create tunnels, and they kind of drill over or mine over to the pipe itself, extract stuff out this way. So that's kind of the evolution of a kimberlite pipe. They're fantastically weird to see from the surface. I believe this is a kimberlite pipe in one of those, the ones in Russia. So you can see this was the old pipe that was mined out from the surface. And after a while, again, that process just became too costly, too expensive, too dangerous. So then they said, you know what, we'll just drill down on the side and then drill into it from underground. We'll drill into the side. Just to kind of give you a visualization of how big this really is. I mean, you can see how big it is compared to this part of the city here. But zooming in even closer, I mean, look at these these are big buildings. These are, let's see how many stories. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's a 10-story building. Compared to this hole, that's a big hole. That's a big hole. All right. In any case, magmatic ore processes can in-place material. What did we talk about? Pegmatite, layered settling, and or these kimberlite pipes. Typically with these, you find some gemstones, some other bigger crystallized minerals. You don't typically find, some of those things we normally think about when mining material, copper, iron. You can find some of that material, but those processes have to deal with a little bit a different story, and they have to deal with hydrothermal processes, which we'll talk about when we come back. I'll see you in just a second.